Hi everyone, welcome to Go Classes. In this lecture, we will see non-binary decomposition. So, in the last lecture, we have already seen what will happen when you do binary decomposition of a relation. So, if you have a relation R and if you do binary decomposition means you are dividing the relation R into two sub-relations. So, this type of division, okay, so basically you are getting two sub-relations. So, this decomposition is called binary decomposition. So whenever we do binary decomposition, then whether your decomposition is lossless or lossy, that we can very easily check. Okay, so this decomposition will be lossless. So this decomposition that we have done, so this decomposition will be lossless if the common set of attributes, I can say R1 intersection R2, that is a super key in R1 or that is a super key in R2. So either it should be the common set of attributes, either the common set of attributes must be super key in R1 or the common set of attributes must be super key in R2. So if either this happens or this happens, then we will say that our decomposition is lossless. And you can notice else your decomposition is lossy. Else decomposition is lossy. I can say the decomposition is lossy. Okay, so this is the point. So this is the binary decomposition. Now, when you do binary decomposition, you can apply this condition. Okay, so but when you have non-binary decomposition, okay, in that case, what you will do? So what is a non-binary decomposition? So for binary decomposition, we can very easily see. All we have to do is whether R1 intersection R2, common set of attribute is super key. It is super key of R1 or it is super key of R2. Okay, if at least one of them happens, then we will say lossless decomposition. But you can notice if your decomposition is non-binary decomposition, means you are dividing the relation into at least three sub-relations. Okay, so what is a non-binary decomposition? It means basically we are decomposing the relation into at least three. I can say, okay, so this non-binary decomposition, it means basically we are decomposing the relation. We are decomposing the relation into at least three sub relations, so you can notice this type of decomposition is called non-binary decomposition. For example, if you have a relation R and you are decomposing this relation R into R1, R2, R3. So this decomposition is a non-binary decomposition. I can say that this is non-binary, because binary means you are getting two sub relations and non-binary means you are getting, okay, more than two sub relations. So in this decomposition we are getting three sub relations, so this is a non-binary decomposition. Okay, so you can notice this is the point. For example, let me give you a concrete example. Let us assume you have a relation R A B C D and we are dividing this relation R into three sub relations. So let's assume R1 is AB and let's assume R2 is BC and let's assume R3 is ACD. Okay, so you can notice this is a non-binary decomposition. So this decomposition, because we are dividing this relation R into three binary relations. Sorry, this relation we are decomposing into three sub-relations. So I can say this decomposition is non-binary. This decomposition is non-binary decomposition. Okay, now in this case when you have a non-binary decomposition, then you cannot apply this condition, because in this condition what we want only, okay, so this condition will work only when you have binary decomposition, remember. So this is a very important point, that this condition, this checking, this testing, so this test will work only for binary decomposition, I can say. Okay, so this testing will work, this testing will work only for binary decomposition, only for binary decomposition. If you have a binary decomposition, then this testing can work, but if you don't have a binary decomposition, then we need something else. Okay, so you can notice this testing will work only for binary decomposition. Now, so when you have a non-binary decomposition, then how to find out whether this decomposition is lossless or lossy? This is a question that we should ask. Okay, so for that we have something called, there is an algorithm, and that algorithm is known as the chase algorithm. Okay, so basically this algorithm, this testing, I can say this testing, okay, what we can say that, okay, testing if a non-binary decomposition, testing if a non-binary if any binary decomposition, actually I can say this algorithm will work for any decomposition. Okay, so remember, testing if any decomposition, binary or non-binary, it does not matter, this algorithm will work for any decomposition. So testing if any decomposition, binary or non-binary, binary or non-binary. So whether you have binary decomposition or non-binary decomposition, this algorithm will work for any decomposition. Testing if any decomposition is lossless or lossy. Okay. So what we can do, we can apply the chase algorithm. So there is a chase algorithm here. So this is not that Satran chess, this is not, this is just okay. So there is a mathematician chess who proposed this algorithm. So that is the reason this is known as chess algorithm. So we can apply the chess algorithm here. Okay, so let me tell you this chess algorithm we will see after some time. Okay, so in the next lecture I will tell you this chess algorithm, but in this lecture let me tell you that can we, okay, so there is another method actually which many students apply, but that method, let us see whether that method is correct method or not. So this chase algorithm, this we will see in the next lecture. In the next lecture we will see this chase algorithm, but let us see whether there is some other method or not. Without this algorithm, can we find out whether our decomposition, whether our non-binary decomposition is lossless or lossy? Okay, so there is one method which is used by many people, but let me tell you that this method is not correct. Okay, so this method is actually used. Okay, so what this I can say this successive combining method. Okay, so let me call it successive combining method. So this successive combining method is used by many students, they use this method. So but this method is wrong. Actually I will prove it. I will give you example where this method will not work, where this method will give you wrong answers. So this successive combining method, okay, to check lossy or lossless decomposition, to check lossless decomposition, to check lossy or lossless decomposition. So let me tell you that this method, first of all, this method is only one way. So okay, we will see what is this method, we will see, don't worry. But I am saying that this method is only one way. So remember, this method is only one way. This is one way method. What it means, that if this method says that lossless, then answer is lossless. But if this method says lossy, it does not mean that you have lossy. So remember, so this method is one way method. What it means, that if this method says lossless, if this method answers lossless, if this method if this method gives you answers lossless. So if this method tells you that this is lossless decomposition, then decomposition is lossless, then answer is will be lossless, then decomposition is lossless. Okay, so remember, if this method gives you answer lossless, then the decomposition will be lossless, no problem, then decomposition will be lossless. But if this method gives you answer lossy, then the answer may or may not be lossy. So remember, if this method gives you the answer lossy, if this method says that the answer is lossy, then the decomposition may or may not be lossy. Remember, okay, remember. So that is the reason this is one way method. So if this method tells you answer is lossless, then the answer will be lossless. But if this method tells you answer is lossy, then decomposition may or may not be lossy, may or may not be lossy, may or may not be lossy, or I can say may or may not be lossless. So remember, this method is only one way. So if this will tell you lossless, then the answer is lossless. If this tells you the answer is lossy, if this method tells you the answer is lossy, then the answer can be lossless or lossy. Okay, so let us see what is this method. First of all, what is this successive combining method? What is this successive combining method? So this successive combining method works like this. Okay, so this successive combining method, it works like this. So let us assume you have a relation R, and this relation you are decomposing into, let us assume R1, R2, R3, R4. So let us assume you are decomposing into four sub relations. Now this method says that what you do, successive combining method. So these sub relations you have, and we want to find out whether this decomposition is lossless or lossy. So what we can do, this method says that what you do, you combine. Okay, if there is a way to combine okay, these sub relations, okay, taking two at a time in a lossless manner. If there is a way we can combine all of them in a lossless manner, then we will say that our answer is lossless. So remember, this method says that if there exists a way, if there is a way, if there is a way to combine, if there is a way to combine these sub relations, okay, if there is a way to combine these sub relations, okay, I can say if there is a way, if there is a way to combine these sub relations, taking two at a time, taking two sub relations at a time, or I can say combining two relations at a time, okay, what I can say. So the point is, if there is a way to combine these sub relations by combining two at a time, by combining two sub relations at a time, by combining two sub relations at a time, okay, so by combining two sub relations at a time, okay, in a lossless manner, in a lossless manner, okay. So if you combine all these, remember this is the very important point, if there is a way you can combine all these sub relations, so if you can combine all these sub relations, okay, by combining two at a time, for example you are combining these two, then you are combining, for example, maybe these two, then you are combining, okay, like this, okay. So you can notice, if there is a way to combine these sub relations by combining two sub relations at a time in a lossless manner, then I can say then decomposition is lossless, then our decomposition is lossless. So I can say then decomposition is lossless. But if there is no way, remember, but if there is no way, but if there is no way, okay, but if there is no way to combine them in lossless manner, okay, but if there is no way to combine in lossless manner, to combine all sub relations in a lossless manner, all sub relations in a lossless manner, or I can say, so if there is no such way, if there is no such way, okay, if there is no such way to combine, I can say if there is no such way to combine, then remember we cannot say anything, then remember we cannot say anything, then we cannot say anything, because the answer can be lossless or the answer can be lossy. So in this situation we cannot say anything. This is a very important point, because this algorithm is only one way. So if you can do, if you can combine two at a time, okay, you take two at a time, and if you can combine them in a lossless manner, then we will say that our decomposition is lossless. But if you cannot do, but if, okay, this is very important, but if there is no way to combine them, okay, to combine, okay, to combine, then we cannot say anything. The answer can be lossless or lossy. So first you check out, okay, let's check out whether the what is this algorithm. Let us take this example. So here you can notice the relation R, okay, so the relation R ABCD, this relation R ABCD, and the functional dependencies are given to you. So the set of functional dependencies are A determines B, B determines C, C determines D, D determines A. So the functional dependencies are like this: A determines B, B determines C, C determines D, D determines A. So here you can notice that what are the candidate keys. So you can notice A can determine everything, B can determine everything, C can determine everything, D can determine everything. Actually, in this relation, if you find the candidate keys, then A is a candidate key, B is a candidate key, C is a candidate key, and D is a candidate key. Okay, so you can notice, first of all, this is the point. Now you can notice the decomposition is given A, B, B, C, C, D. So this decomposition is given. So this decomposition D, let's call it this decomposition D is given, which is A, B, B, C, C, D. A, B, B, C, C, D. Okay, so this decomposition is given to you. Now let us see. Now let us see whether this decomposition. First of all, this is a non-binary decomposition. You can notice. First of all, this is non-binary. Because this is non-binary decomposition, so we cannot apply the condition of binary decomposition. This is the non-binary decomposition. So what we have to do? Okay, so we will see the chess algorithm in the next lecture. So actually, okay, whenever you have non-binary decomposition, then in that case, whenever you have non-binary decomposition, then in that case always, okay, apply the chess algorithm. So you should apply chess algorithm, but the chess algorithm we will see in the next lecture. In this lecture we will see how to apply the successive joining method. How to apply the successive joining method? So what is the successive joining method? I told you that if you can join two relations at a time, so these are the sub relations. R1 is given to you, R2 is also given to you, and R3 is also given to you. So these are the sub relations R1, R2, R3. What we want to do, we want to combine R1, R2, R3. Okay, so these sub relations we want to combine. If you can combine them in a lossless manner by taking two at a time. Okay, so take two at a time. I don't know which two. Okay, if there is a way to combine them by taking two at a time, and if you can combine them in the lossless manner, then our decomposition is lossless. Okay, but remember, if you cannot do it, if you cannot combine them in a lossless manner, then we cannot say anything. Okay, then we have to apply the chess algorithm. So the chess algorithm we will see in the next lecture. Now you can notice, so these are the sub relations R1, R2, R3. Let us see whether we can combine them or not. Okay, so let's see, can we combine R1, R2? So let's see whether we can combine R1, R2 or not. So this R1, R2, can we combine them in a lossless manner? Yes, we can combine, because you can notice R1 intersection R2, that is B, and you can notice B is a candidate key. B is a super key in R1, R2. Actually, this B can determine R1 also, and this B can determine R2 also. Okay, so I can say R1 intersection R2, that can determine, that is a super key. So the common set of attributes of R1 comma R2 is a super key in R1, is also super key in R2. So I can say that we can combine R1 comma R2 in a lossless manner. Okay, so basically this is what we can say. We can combine, what we can do, we can combine R1 comma R2 in a lossless manner, losslessly. Okay, I can say we can combine them R1 comma R2 losslessly. Okay, so we can combine them in a lossless manner. Now what we got, when we combine them, then what we get a new relation. Okay, that is R12, in which you have three attributes A, B, C, and this we already have R3, which is CD. Okay, so R3, which is a CD. Now you can notice we have these relations. So this is a sub relation, this is a sub relation, and now what you can do, can we combine them in a lossless manner? Let us see, can we combine them in a lossless manner? So again, what you will do, you will find the common set of attributes. Okay, so what is the common set of attributes between this and this? So the common set of attributes is C. So here common set of attribute is C, and now find out, is this common set of attribute is a super key in R12 or R3? Yes, it is a super key. Actually, this is a super key, this is a super key in both the tables. This is a super key in both the tables. So you can notice this common set of attributes, this can determine both these relations. This, okay, this relation also can be determined, this relation can also be determined, because you can notice this is the common set of attributes, and C can determine everything. We have seen C is a candidate key, so of course C can determine everything. So this is a super key in both these relations. So finally I can say that we can combine these two relations. Okay, so these two relations, these two sub relations, we can combine them in a lossless manner. So finally I can say that we can combine R12 comma R3 losslessly. Okay, so we can combine them losslessly. So finally what we got, now you can notice we can combine all these sub relations, all these three sub relations we can combine in a lossless manner. So we can say the answer is lossless. So remember, because we can combine, finally we can combine all these sub relations, since you can notice, since there is a way, I can say, okay, since there is a way, to combine, okay, since there is a way to combine all sub relations, since there is a way to combine all sub relations by taking two at a time, by taking two sub relations at a time. Okay, so this is what we have done, yes or no? So we have taken two sub relations at a time. So we were taking two sub relations at a time. So you can notice, first we were taking these two sub relations, then we were combining them, then we were taking these two sub relations, then we were combining them. So you can notice, since there is a way, to combine all sub relations by taking two sub relations at a time in lossless manner, in lossless manner, so decomposition is lossless. So this decomposition is actually lossless, because I told you that if this method, if this successive, okay, I can say this successive combining method, I can say. Okay, so this successive combining method, if this gives you answer lossless, then answer will be lossless. So this decomposition is really lossless. So this is really lossless, because this method is saying, this successive joining method is saying that answer is lossless, so the answer is lossless. But if this method says the answer is lossy, then we will have to apply the chase algorithm, because when this method says that answer is lossless, then answer will be lossless. But if this method says answer is lossy, then we cannot be sure. Okay, then answer, okay, then we cannot be sure whether our decomposition is lossless or lossy. Let us see one more example of this successive combining method. So okay, remember this successive combining method we are looking at. Successively we are combining them by taking two at a time. We are taking two and we are combining, we are taking two, we are combining, we are taking two, we are combining. So finally we are combining all the sub relations and we are creating the final relation. So if you can do this in a lossless manner, then we can say that our answer will be lossless. But if you cannot do it, then answer can be lossless or answer can be lossy. This we will see. I will tell you one example where you cannot combine whatever you do, in whatever way you combine them. Okay, but you can never combine them in a lossless manner by taking two at a time. If you take two at a time and you combine them, if you try to combine them, then we will see one example where you cannot do this in a lossless manner, but still that decomposition is lossless. So that is the reason in the next lecture we will study the chase algorithm. So let's see this example, and for this example we will apply the yeah. So for this example, let me apply the method of successive successive joining. Okay, so successive combining method, let me apply. So here the relation R is given to you, and this is A B C D E. Okay, so relation is A B C D E H. So this is the relation, and set of functional dependencies is also given to you, and this is saying A determines B, A determines C. So A basically determines B, C, and you can notice E determines C. Okay, so E is determining C, and you can notice E. So A is determining BC, E is determining C, D is determining EH. D is determining EH, and you can notice AH is determining D. So this AH is determining D. Okay, so this is the set of functional dependency that is given to you, and the decomposition is given to you R1, R2, R3, R4. Okay, so this R1 is given to you ABC, ABC, and this R2 is given to you, which is EC, which is EC, and R3 is given AHD and then DEH. So this is AHD and then this is DEH. Okay, so this is the set of, this is the, or you can notice. Okay, so this decomposition is given to you. This is non-binary decomposition. You can very easily see that this is a non-binary decomposition, and when you have non-binary decomposition, you cannot apply the condition of binary decomposition. So you, what you have to do, I told you that you can apply the, if you want you can apply the successive combining method. Let me tell you that we will see chess algorithm, and chess algorithm is actually, it will take less time. There is a algorithm, chess algorithm will take less time, let me tell you. Okay, so chess algorithm, we will study this chess algorithm for non-binary relations. So whenever you have non-binary decomposition, for this non-binary decomposition we will see. So for this non-binary decomposition, how to check lossless or lossy, how to check lossless or lossy, how to check lossless or lossy. So for this there is an algorithm which is called chase algorithm, and this is actually very time efficient algorithm. You, it will not take time. Okay, this is actually, it will take less time. The point is this. Okay, it will take less time. So this chase algorithm, and this takes very less time, this takes very less time, I can say, takes very less time. Okay, so you can notice this is the point now. Okay, anyway, let's try the successive combining method. Can we combine them? I don't know which two I should combine first, I don't know, because that is the problem with this successive combining method. In the successive combining method, you don't know where to start, you don't know which two I should combine, basically, because okay, you, okay, maybe we, I should combine these, I should combine these, I don't know. Okay, so that is the problem with this method. So this method will take a lot of time. Also this method is only one way. So if this method will take a lot of time, it will give you the answer, either it can give you answer lossless or it can give you answer lossy. If this method gives you answer lossless, then answer will be lossless. But if this method gives you answer lossy, then answer may or may not be lossless. So that is the problem with this method, with this successive combining method. This is the problem. Okay. Anyway, so let's apply this successive combining method in this question. So what I should combine? So let us check it out. Okay, so first of all, can I combine them A, B, C, E, C? The common attribute is, I can say, okay, can I combine them? Basically, can I start with 1, 2? Can I start with these two? Can I combine them? You can notice that the common attribute is C, and C cannot determine. You can very easily see C is not a super key in R1, R2, so we cannot combine 1, 2. Okay, so we cannot combine 1, 2. Now, can I combine? Okay, so let me see. Can I combine R1, R3? Yes, I can combine them. What you can do, you can combine R1, 3. This is what you can do, because in this R1, in this R3, the common attribute is A, and A is super key here because A can determine BC. A can determine BC, so that is the reason I can say, you can notice this is the common attribute, this is the common set of attribute, and this common set of attribute A can determine BC, so this is a super key in R1, so that is the reason I can combine R1, R3 in a lossless manner. So let me combine R1, 3. So finally I got A, B, C, H, D. This is what I got. Okay, this is R1, 3. Now I have R2 and R4. So remember, now this is gone and this is gone. Now I have R2, R4, R1, 3. Now can I combine them? So first you check, can I combine R2, R4? Yes, we can combine, because the common attribute is, the common set of attribute is E, and you can notice E can determine C. So finally I can say that common set of attribute is super key in R2. So this common set of attribute, okay, R2, R4, the common set of attribute is E, and E is super key in R2. So we can combine these two. What I can do, okay, so I can combine R2, 4. Let me combine them. Let me check. So E, C, D, H. Okay, so this is our R2, R4. Okay, so these two I can combine in a lossless manner. Now let us see. Now these are gone. Now these two are remaining. Can I combine them in a lossless manner? So what is the common set of attributes here? So you can notice here the common set of attributes EC. Here the common set of attribute is C. The common set of attribute is DH. Okay, so CHD. This is the common set of attributes. Now find out what is the closures, what is the transitive closure of CDH. So CDH can determine CDH. Now D can determine EH. D can determine, this D can determine EH. Okay, and you can notice. So finally we got CDHE. CDHE. Yes. So you can notice the common set of attribute between R1. Okay, so here the common set of attribute, this is the common set of attribute, this is the common set of attribute, and this is a super key in R24. So you can notice this is a super key. So R13 intersection R24, R13 intersection R24, that is what, that is CDH, that is CDH, and this is a super key. This is actually, I can say, this is a super key in R24. This is a super key in R24. So because this is a super key in R24, so we can combine them. So what we can do, because this is a super key in R24, so finally I can say that this intersection, okay, R13 intersection R24, this can determine R24, so we can combine them. So these two we can combine in a lossless manner. So finally we will get R3, okay, R1324, R1324, which is nothing but A, B, C, D, E, H. All the attributes we got. Okay, so we got A, B, C, D, E, H. So finally we got our relation in a lossless manner. So you can notice, because finally we got our final, this relation we got in a lossless manner. So I can say, so there is a way, I can say, so there is a way, so there is a way, remember, there is a way to combine, there is a way to combine. So because there is a way to combine sub relations, all sub relations, okay, taking two at a time, because there is a way to combine all sub relations. Okay, so because there is a way to combine all sub relations, combining two at a time, taking two at a time, I can say, taking two sub relations at a time, taking two sub relations at a time, okay, in a lossless manner, in a lossless manner, in a lossless manner we have combined them. So because there is a way to combine all of them in a lossless manner, so decomposition is actually lossless. So this decomposition, the answer will be lossless. So decomposition is really lossless. So this is the point. Okay, so this is the final point, that this decomposition is lossless. Okay, so but remember, can you notice that this method is will take a lot of time? First of all, how do you know that you have to combine this and this? This is what we did. Can you notice that first we combine r1 and r3, this r1 r3, this we are combining. But okay, you can notice first you will try r1 r2, then you will try r1 r3. So you can notice when you try r1 r3, then you will check it. Okay, now then you are combining r2 r4, then you are combining these two. So you can notice this method is taking a lot of time. Okay, this method, this successive joining method will take a lot of time, and also this is only one way. So that is the problem with this method. Okay, so that is the reason in the next class we will see chess algorithm, and this chess algorithm will take very less time. Okay, first of all, and this is actually the algorithm, this is actually the algorithm for non-binary decomposition. Actually, this algorithm will work for any decomposition, binary or non-binary. For any decomposition, this method will work. Okay, this chess algorithm will work. Okay, so this chess algorithm we will see in the next lecture. But okay, so I hope this successive joining method is clear to everyone. If anyone has any doubt, you can ask your doubt in the comments. I will answer it. Okay, but what's the next lecture? In the next lecture, we will study the chess algorithm, which is a very nice algorithm, very efficient algorithm, very simple algorithm, and it will take a very less time. Okay, it will not take this much time. Okay, so this chess algorithm is more efficient than the successive joining method when you have four or more sub relations. So if you have four or more sub relations, if you are dividing your relation into four or more sub relations, then the best method is chess method. So the chess method we will see in the next lecture. Okay, thank you everyone.